Welcome back to our session. Hope you've had lunch and you're all ready to take in the session that we're starting now. Please settle down now that we set the stage to understand the big macro picture for coal gasification in India. We will now explore the technical issues regarding technology and the process at a micro level. Now, coal to gas technology has been around for nearly 100 years and has been refined over the years. Yet, in a country which depends on imports to meet 85% of its oil needs, there are very few coal gasification plants running. Now, has the availability of coal been a constraint? Does the low calorific value and the high ash content of Indian coal make gasification costly and energy inefficient? In this technical session, we have presentations to throw light on the challenges and opportunities for gasification as emerging clean technology in India. So please welcome our speakers, our guests who are joining us to take us through the presentations that they have and how we can overcome the challenges that exist when it comes to gasification processes and technology in our country. I would like to welcome our speakers who are going to be giving the presentations. We have Mr. V.R. Sharma, Managing Director of Jindal Steel and Power Limited. We have Dr. Andrew Minchener. He's General Manager, IEA Clean Coal Center, and Mr. Varun Kumar, Managing Director of Dev Energy, who will be taking us through the presentations. At the outset, we'll start with Mr. Sharma. Mr. Sharma, I'd request you to please unmute yourself and start with the presentation, sir.
Thank you very much, and good afternoon to everybody who is attending this webinar on gasification. I'm pleased to inform you that in steel sector, first time in the world, we are making DRI and then DRI to steel through a coal gasification route. Perhaps we are the first plant in the whole world who has ventured in this particular technology. We produce syngas, that is synthesis gas from high ash Indian coal, and finally we use this gas into DRI kiln, and this is already a reformed gas at 33,400 kilocalorie. We maintain H2S below 2 ppm, and we have 7 gasifiers, Lurgi base, fixed bed type, and these gasifiers put together produces 225,000 nm cube of syngas every hour. And this is an online hot supply to the vertical kilns. And then, we are producing about 220 tons per hour of hot DRI. This hot DRI is directly fed into electric arc furnaces, and we produce steel out of this. So we conceived this project way back in 2007. Then we started hunting for the right technology. We found Lurgi supplied this kind of gasifiers in Sasol in South Africa, where they are using these gasifiers to produce syngas and syngas to diesel or syngas to petrochemicals, syngas to petrol. So that prompted us and that encouraged us to utilize this syngas to produce DRI. So we ordered in 2008 the technology and the proprietary equipments on Lurgi, Germany. Finally, the project came into operation in 2014. This project was based on the coal mines allocated to us in the vicinity of our plant, about 8 kilometers away. But unfortunately, these coal mines were cancelled by Honorable Supreme Court and Government of India in the year 2014. And we couldn't run the plant initially. Finally, we imported some coal, but it was very expensive. But of late, we found that Coal India and MCL, they increased their production in and around Angul in Odisha, and we started getting coal from them. All this coal is very high ash coal, and it contains about 48 to 50% of ash. So what we do, we clean the coal. This is basically a washery. So this washery is used to clean the coal from 48 to 50% of ash to 32% of ash, with a calorific value of 3,500 to 3,600 kilocal per kg. It is still very low calorific value. And finally, we take it to our gasifiers where we produce raw gas. Then raw gas is cleaned. It goes through rectisol, and then finally it goes to DRI. So in this entire process, we also produce some of the byproducts like tar, gas oil, ammonia, and pure sulfur. The sulfur content in gas are hardly less than 2 ppm. So entire sulfur is recovered through rectisol unit. So overall, there is a cost economics today when we compare with the sponge iron manufacturing through direct SRN kiln versus producing sponge iron or DRI through vertical kiln, that is Midrex technology. Also, the HY also has similar technology, similar to Midrex. So we are now utilizing this syngas to produce this DRI. We also add coke oven gas into this stream. So nowadays we are using 70% of syngas and 30% of coke oven gas. And finally, we produce 225 tons per hour of DRI. This is a hot DRI, as I explained earlier. So there are not many advantages today if we convert Indian highest coal into syngas, and then syngas can be used either for making DRI or producing power generation basically, or we can utilize it to produce petrochemicals, including coal to liquid, that is HSD or methanol or petrol. And it is quite economic when we consider the direct burning of coal versus using syngas through a gasification route. Presently, our cost is coming to about $6 per MMBTU. And we are working as to how to bring it down to below $5 per MMBTU. India, as you know, we don't have gas, natural gas. So still $6 is also workable for an operation like ours. I'll now run you through a small presentation so that you can understand what we have and what are we doing. Before that, I'll tell that India has third largest reserve of coal, and God has bestowed a lot of coal to India. Of course, it is very high ash coal. If we burn this coal, utilize this coal in the furnaces, in the open furnaces or in the boilers, then the CO2 emission is very high. But if we utilize this coal through coal gasification, whether it is on surface gasification or coal bed methane or underground coal gasification, which the technologies are available today worldwide, then whether we produce power or we produce fertilizer, the utilization of energy that goes as high as to 60% of the overall calorific value utilization, as against of 32 to 35% through the Rankine cycle. So the advantages are many. We did so many experiments, then only after so many years of operation we could reach to this kind of perfection, I would say. We also tried earlier a producer gas plant for our pellet plant manufacturing in Badbil, but there we failed to produce or to gasify the right amount of and right quality of gas. But here in Angul, the gasification through Largi route, we could find, yes, it is a successful route. And there are more than 500 gasifiers working worldwide. We have 7 of them. And the majority of the population of these gasifiers is in China. And we feel that the technology is quite good. The other technology is the entrant flow. In fact, in India, in the year 1975, two entrant flow-based gasification unit came. One, both were in the public sector. One was in Ramagunda and the other was in Talcher. So Talcher, they ran this Talcher plant up to 1998, and finally they abandoned it after the operation of about 23 to 24 years. Now again, Government of India is putting a new plant in Talcher. That will also be based on entrant flow, where they will use the microfines of coal, which is quite possible. So our process and entrant flow process, two are the different processes, because in entrant flow you need ash below 25, or they prefer to 15, whereas in the fixed bed type we are running at 34 or 35% of ash. So I'll just run you through with our presentation. So this is a path for the technology, the Gasification India 2020 we are discussing today, and Honorable Prime Minister Mr. Narendra Modi in USA, one day he was replying to a press reporter, and just I'm showing you a clip of just few seconds. Please have a look.
You talked about plastic, water, renewables. Do you have any expectations of reducing the amount of coal that is burnt? ये बताइए कि दुनिया का तीसरा सबसे ज्यादा
So rightly said by Honorable Prime Minister, how can we utilize the coal gasification with the environmental friendly route? You must be seeing a layout. It looks like a refinery. This is the plant what we have in Angul in Odisha. I'll invite all of you, whosoever can visit our plant. It is running very well, 24/7. If somebody wants to visit this plant, then it is a great technology demonstration as well as learning. So one can visit. If you see some of the areas, like for example, on right hand side you see the gasification block. Then after gasification, the raw gas cooling. Then you are seeing the two vertical columns. These are called rectisol columns. And here we reduce the H2S, that is sulphur. Then it comes to ammonia recovery, where NH3 is recovered, ammonia. Then we remove phenol-solvent, and also the gas liquor separation. So this is the simple layout, but the equipments are very complex, and you have to maintain them very well to reach to the right quality of gas. This is the process. Normally worldwide people, they adapt to produce DRI. So in DRI, this is called mid-rack shaft DRI. Similar DRI shaft is from HYL, that is Mexico. They are the two large suppliers. So what we do, we feed the syngas into the vertical shaft furnace. And from the top, the iron oxide, you can say pellets. These pellets, they do come, it is like a cupola or blast furnace or any other converter. and the gas goes from bottom, and the iron ore pellets, they are coming from the top. Though I'm telling very simply, but it is not so. Then there is a top gas recovery. It goes through scrubber. Then finally, the CO2 is removed, and then again it is recycled. It goes to the gas heater and again goes to the vertical shaft kiln. This is a chain process. If you see on the left hand side, we produce coal to gas, and then gas cleaning system, also hydrogen sulfide removal, H2S removal system, and then there is a turbo expander, because the gas which is coming from the gasifiers is coming at a pressure of 22 bar, and we need in kiln only 2 bar. So we have put up a turbo expander, or you can say a power generation system. This is where we generate power, and this power is sufficient enough to meet out the requirement of the DRI plant. That was the layout, and this is the real picture at night. How does a gasification unit look? So if you see, then these 2 vertical towers, you are seeing the rectisol towers, and a small tower is a methanol charging unit, and the left hand side tower is ammonia recovery tower. Then you are seeing 6 tanks, big tanks. This is called tank farm, and for various byproducts. And finally, you are seeing the left hand side, the big gas pipeline coming. So this gas pipeline is going to our DRI plant. It is online. There is no storage or reservoir in between for the gas, because gas is the gas is at 22 bar pressure. The other is we need a continuous flow of gas to the plant, and it cannot be stored in between. And the consumption is pretty high. We are nowadays consuming about 120,000 nm³ per hour, and balance we are utilizing our coke oven gas. There is also another view for the gasifiers. You will see that the front side is the gasification unit, and right hand side the cleaning units. And this is how it looks. It looks very clean, very green. There is no smoke, nothing. You won't find any smell, or you not find any SOx or NOx in the area. So whether you gasify above the surface or under the surface, the environment is fully taken care of. This is our DRI plant. If you see there is a conveyor belt from left to right at a 45-degree angle. So this is the conveyor which carries the iron ore pellets, and it is charged from the top, and from bottom we feed the gas. It's a very complex process. There are so many equipments in between, and like turbo expander, and then the gas mixing bustle. Then when the methane is very high, CH4, if it is more than 6%, then we add oxygen into it, so that we can convert CH4 into CO2 plus H2. So, and that become a reactant. And finally the top gas removal system, and then top gas dust removal system, finally CO2 removal system, and then the gas is again recirculated. This plant is in between the hills. All 4 sides of this plant you will find very green hills, and we maintain the gas quality, the CO2 emission system, the SOx and NOx in such a way that the environment is protected fully. So all of the greeneries around, that is a certificate of our controlled chemistry, as well as very, very controlled environment norms. There is no pollution. That's why I not use the word of controlled pollutants, because there is no pollution at all. These are the 7 gasifiers. If you see on the right hand side, there is a blue sheet. There is a blue vertical panel, and on the right side there are 7 gasifiers. And we normally run 5 gasifiers, and 2 gasifiers, they are in hot standby condition. And suppose there is some breakdown or some ash is locked into it, or some conveyor is creating some problem, and then immediately we switch over. And during the cooling process, we also produce steam from these gasifiers. This is a gas cooling unit you are seeing left hand side, and just at 90 degree to us, it is a ammonia recovery plant. This is another view. This is showing again 2 rectisols vertical columns, and left hand side is the ammonia recovery plant. Again, the rectisol unit. We are showing a little close up so that you know that how does this plant look. It's just not burning coal somewhere and then you produce syngas. There is a difference in producing producer gas versus syngas. So as I told you, we also started making some producer gas, and that was not a good experience. That was in another plant in Odisha. But here it is a success story, and it is like a refinery, I would say. This is Solvent Plant unit. If you see the surface, the floor area, you will not find any spillover of any kind of chemicals or dust or coal dust or particles. It is as clean as a good street or a good house. And that's why I was telling that any one of you or all of you, whosoever wants to visit, I'm extending the open invitation on behalf of Mr. Jindal, our chairman, and on behalf of our company and on my behalf. We believe in dissemination of knowledge, and we expect that more number of plants will come in this country. As Honorable Prime Minister was telling, that we are interested in coal gasification units. We have already done it, I would say 6 years back. We conceived it about 13 years back. Prime Minister has given the thrust now in 2019, but we were already in operation since 2014. Ammonia recovery column you are seeing, and sulfur recovery unit you are seeing on the right hand side, where we take out the purest form of sulfur, what we sell in the market, and ammonia also we sell in the market, liquid ammonia. These are some of the slides which you will know, and this will also make you able to understand what this gasification meant for India. The clean energy technology to harness a huge high coal reserves is a must, as highlighted by Honorable Prime Minister Mr. Modi. And this will make India Atmanirbhar for sure, because this is import substitution. Basically, we do not need to import crude oil. If we convert at least 300 million or 400 million of coal every year, we can meet out at least 40 to 50% of the country's demand in terms of energy, whether it is SNG or coal to methanol or coal to liquid, that is HSD, or coal to petrol, benzene, coal to last product of polyesters, that is olefins, that also can be produced very well. Basically, all of the refineries in India, they should be asked by Government of India, at least 25% of their product should be from coal, through coal gasification route. And that will definitely help the nation to make India self-reliant in terms of requirement of energy. Then we convert low-value feedstock to high-value products. This creates a lot of employment in the country, and there is a overall development of mines. So this is how we do. Like if you see the gasification value chain, coal, pet coke, used tire can be gasified. Then synthesis gas can be produced, which has 60% of H2 and 30% of CO, that is carbon monoxide, and balance 10% is like CH4 and other gases. And the process is as follows. Iron ore is reduced through DRI process, and then finally the hot DRI goes to the electric arc furnaces, which is the cleanest form of making steel, and it does not need any coke oven, does not need any blast furnace. So you just need electricity and DRI. And then H2, if we produce H2 from gasification, coal gasification, we can easily produce ammonia and urea. Now hydrogen is in great demand in many of the developed countries, like in UK, Sweden, and many of the countries like Finland. They are already converted their transport system, city transport, into hydrogen buses, and I think that's the future. So we can convert coal into hydrogen also as a fuel. Then we have a process like Fischer-Tropsch process, FT, and with this process we can produce from coal to jet fuels, coal to diesel, coal to naphtha, coal to PVC, LLDP, HDP, and olefins. Then again coal to power and steam, and then coal to chemicals and gas production. We can produce SNG, that is synthesis natural gas. We can, of course, we are producing CO, CO2, O2, nitrogen, argon, everything is possible from coal. Then methanol and ethanol can be produced. Industrial chemicals can be produced, and sulfur or sulfuric acid can be produced. One thing I have missed here, that is ABP, that we can produce for the medicines, and which is a very hot commodity as of now. Syngas versus imported LNG. As I have already told you, that target for syngas cost, if coal cost is 45 paisa, that is half of rupee per megakal, then making the industry competitive. So we can produce at $5 per MMBTU as variable cost, and the total cost comes to $7 per MMBTU. This is including interest and depreciation, but the cost for basically variable cost or the actual cost is $5. Then the advantages are, yes, we save a lot of foreign exchange, and India can definitely produce 110 million ton of steel out of this particular route, and there is a huge potential converting coal into fuel, that is the diesel or petrol or SNG. So coal can be used for its chemical energy and used to more value-added products rather than using thermal energy just for power generation. National policy on coal gasification be formulated and promulgated for faster and smooth implementation. To have a senior official in Ministry of Coal dedicated for coal gasification. This is what we are requesting Government of India to facilitate the gasification business, and coal to be made available at 20% lower price than the regulated sector. Nowadays, power is a regulated sector; they get a preferential price. So we are also requesting Government of India to give coal at a preferential price, so that whatever 350 billion ton of coal reserves we have, before the coal becomes a very unfriendly commodity by the world community, we should convert as much as possible the coal into syngas, and finally the last milestone. Getting coal from single source is very important for coal gasification units, because all of the process parameters, right from coal washery to the coal gasification, they can be set right if it is supplied through a single source. That's why many coal gasification units, they are coupled with their own dedicated mines or captive mines. We also requested government to GST compensation cess of 400 rupees should be waived when somebody is utilizing coal to gas process. We are now operating at 40%, but why? Because we are also utilizing our coke oven gas, and now we are working as to how to produce methanol, because we have surplus in gas, and we are adding a unit to produce syngas to methanol. So this is a successful venture, and I'll invite anybody, any question, or anyone wants to visit our plant. He or she is most welcome. Thank you very much.
Thank you so much for your presentation, Mr. Sharma. Sir, would you be here for some time? Because we were thinking we will take the questions, after we have finished with our speakers. Would you be able to stay for some time, sir?
I'll be available. You can take me online.
All right, sir. So please stay with us. And if there are questions coming in, we will take them up. I do see a couple of questions. We'll take them up as soon as all our speakers end. I would now like to request Dr. Andrew Minchener, General Manager, IEA Clean Coal Center, to please start with his presentation and address the audience. Thank you so much, Mr. Sharma.
Excellent. On behalf of the IEA Clean Coal Centre, I'd like to say it's a pleasure to take part in this Mission Energy event. I'm going to talk about global IGCC development and deployment. Excuse me. And I'm going to focus on coal to power and then coal to chemicals and future fuels. This is a broad overview of what I'm going to talk about, which is self-evident. I'm not going to spend great time taking you through all of this. You'll get access to all my slides presentation afterwards, and if you want any further information, you only have to contact me at the Clean Coal Centre and I will provide that. In terms of who we are what is known as a technology collaboration program. We're organised under the auspices of the International Energy Agency, but we are functionally and legally autonomous. We're funded by a mixture of national governments and industrial organisations. Most importantly, we are dedicated to providing independent information and analysis on how coal can become a cleaner source of energy. So our programme is very much aligned with the UN Sustainable Development Goals. This is a picture just of our membership. On the left-hand side is the national governments that support us, and on the right hand side is the industrial sponsors that we have. I'd like to just highlight the fact that among our government supporters we have major ones such as Australia, Japan, USA, for example, but we also have South Africa, a developing country, and all of our industrial sponsors on the right hand side, as you can see, are from industrializing nations. This sets out our program, or how we adapt our program. Said the critical aspect is the UN Sustainable Development Goals. So our whole approach is designed to identify and publicize the best practice in every aspect of the coal production, transport, processing and utilization chain. And we really look at that within the rationale for balancing security of supply, affordability and environmental issues. We can, in our work, which comprises a mixture of detailed policy relevant studies and an outreach program, at least there's an outreach program when we're not hit by the COVID-19 pandemic. And in those two aspects, we consider policy and regulatory issues, financial resourcing, market issues, technology development and deployment, including efficiency improvements, looking at how you can best lower greenhouse and non-greenhouse gas emissions, how you can reduce water use and water stress, and also trying to see how you can ensure poverty alleviation through universal access to robust and reliable electricity. This is just a slide of the reports, the study reports that we've issued in the last 12 months. It's quite a broad mix. For example, I'll just highlight a couple. We've been looking at the modularization systems for clean coal. That's really been part of the Coal First program in the USA. We have looked at water issues for coal-fired power plants. Very important issue, I feel. And we've also been looking at power plant design and management for unit cycling and load fluctuation, where you have to balance the intermittency of variable renewable energy sources like solar and wind with reliable, robust, dispatchable power that you can get from coal, gas, biomass, and hydro. This next slide is showing what we've got underway at the moment. Again, a very broad mix. One I would just highlight is non-energy products from coal. This is quite a new but fast-growing area. You can take low-grade coal and you can convert it into higher-grade carbon products and non-energy carbon products like graphene or carbon fibers. And also from certain coals, you can extract rare earth elements, which are a strategic imperative for all countries, because rare earth elements now appear in your mobile phone and a lot of other communication devices and so on. And the natural resources for these are mostly very limited. Rare earth, it is rare. Other area just highlight here, hydrogen production from coal. Again, I think that's a very important area, and that links into the gasification programs in many respects. Moving on to talking about IGCC, this just sets out the environmental and macroeconomic drivers for developing and deploying technologies. Certainly on the environmental side, you've got climate targets that are increasingly affecting most countries. Most countries, certainly in India, expanding the electricity sector is a key issue, trying to ensure high annual growth, avoiding electricity starvation and having a reasonable reserve margins. And then there's the macroeconomic issues such as higher population growth, low per capita income, and the financial and business drivers. This is a schematic of an integrated gasification combined cycle power plant. Essentially, you can react coal and steam with oxygen, or in some cases air. You can produce a fuel gas that's a mixture primarily of carbon monoxide and hydrogen. From that, you can readily remove mercury, you can readily remove sulphur and CO2. You can then fire that clean syngas in a gas turbine to generate electricity. And when you've done that, there's still a lot of energy left in the exhaust gas, and you can pass that through a heat recovery steam generator to generate more power. It's a relatively complex system. It's a very high capital cost system, but it does have the advantage of readily enabling you to clean the gas. And if you're looking into the future for perhaps carbon dioxide emission removal, this is going to be probably an easier system than the one that we're seeing starting to be applied on coal-fired power plants, the combustion-based processes. Why is it interesting? Well, because there is obviously scope to improve the efficiency of the gasifiers, but equally, as shown in this slide, there has been a number of steps where they have been improving the efficiencies of the gas turbines. And you can see here the types of the higher the inlet gas temperature or firing temperature on the gas turbines, the higher the efficiency. And what it means is that as the gas turbine efficiencies are improved, this offers the opportunity to raise power plant efficiency when you link in the most modern gasifiers to the more modern gas turbines. And it also, as I've said before, offers the opportunity to shift the composition of syngas, remove the CO2 from the gas stream, and you can produce high-value hydrogen that can be used to drive a fuel cell or be used in manufacture of certain products. These are the proven gasification options. As the previous speaker mentioned, there's quite a lot of interest in dry feed and train flow gasifiers. They're probably the more modern units. But there are limitations that you need very finely ground coal. You can either fire it dry or a slurry feed. But then there are alternative systems that are designed to take different types of coal. Moving bed gasifier, for example, takes lump coal, but only lump coal, not fine coal. And a fluidized bed gasifier is very simple, but it's less efficient than the other three examples. So far, from a power plant perspective, this lists the major technology demonstrations and deployments that have gone on. Those in red or reddy brown were the first major demonstration projects which took place in the USA and in Europe. And then the later units, which are essentially are established in Asia, appeared subsequently. So the initial ones were those 4 that I've shown there. This shows the capacities, the operational times, and the issues that occurred. For the interest of time, I'm not going to spend time taking you through that. You could look that through at your leisure, but I will highlight some of the key findings from these various projects. Okay, existing projects. Yeah, the first projects are always going to be more difficult, but there were certain ways that some of these plants were constructed, perhaps lost focus. And the design and integration approaches and the rather inadequate operational procedures led to poor operation. And the fundamental problem with those early plants was the availability was probably at best around about 70%, which is very not high enough. The other key point that these units were designed to maximize efficiency. So there's very close integration of the air separation units, the gas turbines and the gasifier, so that the plant become more efficient. But the more efficient that plant came, the tighter the integration, and that meant operational availability was very vulnerable to any outages from any one of these systems. That caused significant knock-on effects. Surprisingly, also, the performance of some of the components were very susceptible to changes in quality and composition of the coal types that were tested. And some individual pieces of equipment just didn't scale up very well. So they didn't follow the predictions based on small-scale results. Nevertheless, demonstration plants are built for a reason, because it helps you to find the problems. It can be a very expensive reason. This was an expensive learning process. But there was a lot of learning by doing, and that's been fed into the subsequent projects and achieved a rather different picture. So let's move on to the later projects. I'll highlight one from China. This is the Huaneng Green Gem plant based in Tianjin, near a short journey from Beijing. This project was one of a part of their overall projects looking to go to cleaner electricity by various routes. So they've been looking at all of them. They've been looking at post-combustion gas cleanup on combustion plants. They've been looking at the gasification processes and oxy-fuel processes, and also industrial processes, which link rather to the previous speaker's activities. So the first phase of the green coal power plant at Huaneng includes the Tianjin IGCC. That has an installed capacity of 265 megawatts. Unlike these earlier plants, this has had very good operational performance. It's an oxygen-blown unit, has very good operational performance, and in 2018 it achieved continuous operation of almost 4,000 hours, breaking the world record. And since its inception, this project has generated more than 5.8 billion kilowatt hours of greenish electricity. I think it's fair to say the country that's the global leader at the moment on gasification applications is Japan, at least for power applications. And this is showing one of their earliest test rigs. This is an oxygen-blown plant. It's called the Eagle plant, and that stands for Energy Application for Gas, Liquid and Electricity. And its goal was, and has been achieved, to develop a Japanese-built oxygen-blown in train flow coal gasifier suitable for multi-purpose applications. This was a 150 ton per day pilot plant, 150 ton a day of coal, my apologies, with many options, and has performed very well. And I'll come back to that a little while in the future, but you can see here it included the generation of electric power. There was also the production of synthetic fuels, chemicals and hydrogen, and it's also considered polygeneration aspects. And particularly with the hydrogen, they're looking there for using it to produce very clean energy via fuel cell applications for the future. This sets out the demonstration program. Started a long time ago, started in 1995 and ran ultimately through to 2013. And you can see the early stage was developing the gasifier and the clean up technology. The next phase was looking at the multiple utilization options and diversification, trying different coal types, and looking at capture of CO2 from the coal gas stream through chemical absorption, and also looking at trace element behavior. And then the third stage was looking at different approaches to carbon dioxide capture and trialing various advanced developments. It's proved very successful, and as I said, we can talk a little bit more about where that's going in a while. I do also want to highlight the Nicoso air-blown IGCC. In fact, actually, when I say it's air-blown, it was oxygen-enriched air-blown. But essentially, this was a 250 megawatt demonstration plant. And it ran for more than 16,000 hours and then went into commercial operation at the Joban Joint Power Company. It achieved 42% efficiency, and you might say quite rightly, well, that's really quite low. But it was achieved with a 1200 degrees Celsius D-class turbine, an old-fashioned gas turbine. Mitsubishi Power Systems suggests that if you had a bigger gasification unit, a 480 megawatt net plant, that could achieve about 48% with a higher efficiency G-class turbine. And if you had a 580 megawatt plant, you could achieve about 50% efficiency with a state-of-the-art J-class machine. And in fact, on the back of that program, Tokyo Electric Power is actually currently building 2 new plants, IGC plants, in Fukushima Prefecture, and they are both of 540 megawatts individual capacity. This slide shows the the actual Nicoso plant, as I said, which is now part of the Joban Power Company, and it's a good example of a demonstration going through directly to actual deployment. Coming back to the oxygen blown variant, based on the Eagle project, they have a plan for this SAKI cool-gen project, where the intention is to scale up from their small unit. And again, looking at, you can remove CO2 if you shift the syngas reactions over a catalyst. You can get CO2 piece you can remove, and hydrogen can run the fuel cell. The CO2 can be taken away either for utilization or potential storage in a geological formation. I mentioned Japan is taking forward fuel cells. They see this as a very important area for them to move towards zero emission, high efficiency coal power plants. But I think it's fair to say there's still some way to go yet, particularly in the scale up activities. I think one of the other points I want to stress is it's not just about the power plants where the development work is going on. There's a lot of other activities that I've listed in this slide here. Smart grids, virtual power plants, digitalization of the grids, increased flexibility, not least to accommodate the variable renewable energy sources that now have to be populated on the grid. Design side management, helping to manage the variable renewable energy sources, battery storage, and potentially CCUS. Just to take forward one other point, I'd like to say a little bit about producing future fuels from chemicals and future fuels from coal gasification, as that is another option. This is a simple slide. It shows low-grade coal on the left, which you can gasify. You can then adjust your chemical mix. And you can either produce power, but more especially in this context, you can adjust your chemical mix, and you can produce a very wide range of required products in the various industrial and commercial sectors, for use in the industrial and commercial sectors. That looks great, and the coal is low cost, low grade, but the capital cost of these systems is very high because of the complexity of them to make all these potential products. And that is an issue that has to be taken into account. In some cases, it's not, it's going to be a finely balanced decision you take forward this in certain parts of the world. Map of China, which is the by far the world leader in coal to chemicals and future fuels by gasification. The point I just want to highlight here, many of these plants are located in the west or the north part of China. Most of the industrial and commercial sectors are on the east side, southeast side, and south part of China. So whatever you produce has got a long transport system, and that adds to the cost because of the infrastructure that you've got to establish, not just to take the products away and perhaps indeed take the coal to the plants. This program was established by the Chinese state government. First building block they made was ammonia, and then they made fertilizer, then they made hydrogen, they made methanol, then they moved into more complex chemicals and also coal to synfuels, synthetic oils. They've also, and I've listed other compounds here. Two notable highlights from China Energy, which is a major technology development. In 2009, they established a 1 million ton per year product output from a direct coal to liquid fuels process. And in 2017, they produced a 2 million ton per year plant based on the indirect coal to liquids process, essentially the gasification systems I've been showing you in the previous slides. These are both very good plants, and much of the time they're very profitable plants. But these systems are vulnerable to low-cost alternatives such as oil and gas. You can make these products from coal, yes, but you can also make them from oil. You can also make them from gas. And right now, for example, oil and gas prices are very low in much of the world, and I suspect the output from these plants is not much more than ticking over to keep them running. There's another factor that has to be taken into account. This slide shows the gas transport infrastructure. Already, China brings in natural gas from the Stan countries, which again they bring over to the east and southeast and southern part of China. And then there's also other pipelines that are now joining in and linking to those to bring various other chemicals and possible oil-based fuels from coal into different parts of China. So it's a very complex, high-cost infrastructure that's now straddling most of the country. There's we heard already the excellent work that's going on at JSPL Angul plant. There is also coal to methanol activities, I believe, in India. I just want to highlight a project very quickly about in Australia-Japan cooperation. Australia has massive amounts of very low-grade brown coal. I would personally argue it's not coal, it's fossilized wood. You can gasify that, though, to make high-grade hydrogen, which can be pressurized, contained, and shipped back to Japan. And the CO2 that's removed from the process can be stored in geological formations in Australia. There's a lot of work going on to establish a primary demonstration project of that, and be very interested to see how the results come out from that in the future. Just bringing that part to an end, before I cover one other topic, I think the case for coal is very strong. It will need to remain an integral part of the global energy supply for a long-term sustainable future for the world. But at the same time, we've got to look at ways to always looking how we can best improve the efficiency of operation and ensure we get a sound environmental footprint from the various processes. Right, my last few slides. What I'm very pleased is to introduce you to is the IEA Clean Coal Centre's Knowledge Partners Network. The idea behind that is to show global solidarity between organisations that have a positive interest in sustainable coal utilisation. We want to showcase the breadth of our knowledge and that of our partners and to ensure better exchange of information to encourage future collaboration. I'm happy to note that we've had a very positive and growing response from companies since we started seeking members for this network back at the beginning of 2020. And we have membership from commercial companies, from universities and other institutes and organisations who want to become part of this network. I should stress that membership and involvement is free to all members who join up. This shows a page, a sheet from our website, and it's showing a sum of the companies and organisations that have signed up over the last 11 months or so to join our Knowledge Partners network. And so every company that's joined up, we include their logo on our website and ask them to include our logo on their websites. And you can see there a wide range. And if you go to our website, you can see the full range of companies that signed up. We have, actually, this is out of date, so I did it at the beginning of the week, last week. It says 102 there, it's about 108. But of 102 that I've listed here, this shows the countries that have joined, have organisations within those countries have joined up. For India, for example, we have 7 members already from your country, which are very much appreciated. So we have 102 members, we have 27 countries, and 11 of these are from developing countries, which, as you'll recall from my earlier part of my presentation, is where we've been very busy in much of our activities. We're keen to build on our existing contacts to broaden and strengthen our links worldwide. Our membership, contracting party members and our sponsors are very keen to support this. So anyone who is listening to this or has found out about it afterwards who is interested in joining, as I stressed before, it's free. Please contact me or my colleagues by email. And my email is on my final slide, which is here. Thank you very much. I hope that wasn't too much of a rush. I did try to pack quite a lot in. My email address is there for anyone who wishes to contact me. And thank you very much for listening. Thank you.
Thank you, Dr. Minchener, for your presentation. And I'm sure there are a lot of takeaways for the audience from your presentation. We have with us Mr. Varun Kumar of Dev Energy, who's all set to present to us next. And then we can have Mr. Varun Kumar give his talk and his presentation. Thank you so much. Mr. Kumar.
Yeah. So today's topic, that is the challenges and opportunities in coal gasification. So let me start with who we are. We are a company which is focusing on coal gasification since last 16 years. Now, what is the focus here? The focus is to convert coal into a fuel which can be used for heat, furnaces, for making various products like steel, ceramic, alumina, copper, zinc. So many of these products, you need to heat them to get them into final shape. And this has been our focus for gasification, is to convert coal into a usable gas which can be used to fuel the furnaces. This we have been doing for the last 16 years in partnership with a company in China, Yisheng. Now, why China? As both my speakers, partner speakers in this session and earlier in the morning, everybody highlighted that China has taken lead in gasification. And for the fuel gasifiers, Yisheng has been the world leader. They have installed more than 2,000 systems across the world, and which are all running at 100% success. And in India, in the last 15, 16 years, we have done around 180 systems in almost 40 different industries. And this has brought down the cost of production of all these products, all these industries by almost 40 to 50%, because that's the difference. That's the difference in terms of energy cost between furnace oil, which is the primary fuel most of these industries are using, and coal gas. So these are some of our achievements. We have been India's #1 in terms of gasification for glass furnaces, for bone china, for wall tiles, floor tiles, and pellet plants, iron ore fines which are converted into pellet, both to straight gate and rotary kiln. All these technologies, we have been the first in India to install gasification systems to convert their existing fuels into coal gas. What is our technology? The core of our technology is two-stage gasification. This is a fixed bed updraft gasification system which converts coal by gasification in 2 stages. The stage 1 is the up stage, where it converts into where it takes out the VM of the coal, and the second stage is where it converts the coal carbon into CO, methane, and hydrogen, a mixture of these 3 gases. Now, as you can see, the calorific value of both these gases are different. Also, the temperatures are different, compositions are different, and therefore, both these gases are processed through different cooling and cleaning trains, as you can see in the process flow. So this is slightly complex because the upstage gases are taken through this route, wherein they are taken through electrostatic precipitator and then indirect coolers, then again a train of secondary electrostatic precipitators. And the downstage gas is cooled through multiple stages of cooling and cleaning. And finally, all these gases are mixed, and then desulfurization is done on them. And then they are boosted by pressure boosters to meet the pressure required in the cleanse. Now, this system are air fed. So the air and steam, which is generated within the system, is fed as the gasification agent. And this system is a complete island mode, and no external steam is required to run this system. And we have around 180 of these systems running in India, and the oldest one is running from 15 years, and the latest one we have done in a pellet plant is operating at almost 87-88% conversion efficiency from coal to gas and tar. This is a energy balance, a broad energy balance for the gasifier system. As you can see, we can almost convert 78% into final coal gas and around 9% into tar. This is assuming a 5500 calorie coal. And even for the worst coals like the F grade or G grade coals, this total number remains in the range of 75%, both for gas and tar combined. So these are some of the plants I wish to highlight which we have done. This is one of the toughest projects. This is a glass unit wherein we have shifted from the existing fuel to coal gas in a running kiln, and various innovative technologies have been used to make sure that this regenerative type furnace is operable on coal gas. I must highlight, this is one of the first conversions outside China in the world of a glass kiln into coal gasification system. As you can see in this photograph in the center and top, the gas cleaning area, various equipments are shown, and various pipelines and tanks are shown, and you can see the cleanliness level of the system. These are a few of the pellet plants where gasifiers are operating, and you can see the size: 15,000 Nm³ per hour and 18,000 Nm³ per hour, and they are running 24/7, 365 without stop. And normally once in a year or 2 years, shutdown happens. So the reliability is almost 100% on these plants, because they have been designed in such a way that within the plant, the functionality of each equipment is with standby equipments, so that plants can run continuously without interruption. As Sharma ji was highlighting, this is one of the plant in their Patratu steel rolling mill in near Ranchi, where this is 10 gasifiers have been installed. Again, this gasifier ran very efficiently, but due to the lack of suitable coal and coal procurement mechanisms, this is not operating at full efficiency. But technically, this is most suited for the billet reheating furnaces which are at the site, which have been converted to coal gas. Some of our steel plants, we have around 120 steel rolling mills running on gasifier systems. And this is photographs of ceramic plants where our systems are operating. And I must highlight that this is the reason You see, a few years ago, all of you must have heard that the Chinese import tiles have eaten up the Indian market. And in the last 4 years, that talk has vanished. Why has that vanished? It's because of the transformation of these tile making companies from the very expensive LPG fuel to coal gas. And once you run the tile plant on a coal gas, the cost of production is almost lower than the landed Chinese tiles. So these are some of the brands which are running on our gasifiers. Now I want to move on to this is what we are, and now I want to move on to what are the challenges which the ecosystem, the gasifier ecosystem faces in India specifically, and what we have been facing from last 15 years. Policy for coal for gasification. There is no specific linkage available, and all our customers have to buy coal from the traders, and the availability is variable. So because the gasifier needs a consistent flow of one type of coal. So that is the first challenge in our ecosystem. Second is the customer needs a standardized process, a standardized product from us. And when the customer is approached by different technology providers and there is no standardization in terms of what is the output required, what are the safety norms, what are the coal gas quality, so then the customer is very confused and very difficult for the ecosystem to move forward. Then our pollution control boards, state pollution control boards, have no policy. The NGT works on case-to-case basis, and a centralized policy for gasification has not been formed, which creates ambiguities in each state pollution control board's clearance mechanism. There is no agency for any technology certification which can be used to counter these above 2 points. There is no mechanism to de-risk the whole technology absorption with any pilot plants. There is no government support for any pilot plants, and the pilot plants which have been running by some of the agencies have not yielded any commercial results. There are no mechanisms of training of manpower, and finally there are no financial or taxation benefits of saving, as Mr. Sharma was saying, saving foreign exchange, saving crude oil imports. So it's only talk, but nothing has come in terms of black and white from Government of India. But as Dev Energy, what we have done in the last 15 years is to convert these challenges into opportunities, and that's what an entrepreneur should do. What we have done is all the plants which we have installed near to the coal, so that the cost of coal and the availability of coal is easier. We have tried to install plants for the furnaces where the existing fuel has been very expensive and the payback is very fast, so that the customer is able to take the risk and take the impact of unknown variables in the process. We have tried to offer standardized process and product which doesn't change from customer to customer, and we have tried to de-risk all the business by showcasing running plants in India or in China, and we have helped all our customers in NGT and PCB clearances by providing all the relevant informations and required processes to match the expectation of the state pollution control boards. And we have been providing O&M services to our plants so that they are able to achieve the desired results or the committed parameters which we have committed them at the time of sale. Now, what are the technical challenges? The most important technical challenge is the trust in the technology. The customer has to decide whether he has to go for coal gasification system with or without backup fuel. So that decision is a very difficult decision, and we have to make sure that this technical challenge is solved when we go for any of the deal. Now, the second challenge is the size, because in India, the scale is not that big for most of the SMEs, and for the larger plants, the scale is very big. So you have to modify your offer to make sure that you're able to offer plants which are large and which are small. And the third important challenge here is that the technology to convert the existing furnaces has to be taken up by the gasifier supplier themselves, because most of the existing furnace technology suppliers are not interested to shift from their key fuels like furnace oil or natural gas to coal gas. And as I've already highlighted, the technical challenge of meeting the NGT and safety compliance is very, very important. Now, the current challenge which we are facing as a gasifier technology supplier is to move beyond the double stage systems, because the double stage system use sized coal, and most larger plants want to shift from sized coal to fines. And they, as in the morning session, Mr. From SWIN Technologies, speaker was saying that the lighter, younger coals are cheaper available, and gasification technologies are required for those type of coals. So therefore, we have to change the technology from hard and high fusion temperature coals to lighter coals, and increase the carbon conversion, and use the gas without nitrogen carryover, meaning that you have to find a technology which is oxygen blown and or oxygen enriched, so that the nitrogen carryover is very less. And therefore, fluidized bed gasification is the next step for fuel-based gasifiers to adopt all these points. So this is a GA of the fluidized bed gasifier. There's a gasifier with the recirculation of the gas and multi-stage cooling and cleaning system. So these gasifiers are able to use fines. They are able to use soft, low ash coal. They can use oxygen, and they are very large size, can use up to 40,000, can generate up to 40,000 meter cube of gas. And there is no tar generation, no phenolic water generation, and very high carbon conversion, and very easy to start and stop. This is one of the photograph of a plant running in China, firing a alumina calciner kiln. Why I want to highlight in the end that for fuel gasifiers, Dev Energy has been innovative and trying to take up the challenges and convert them into opportunities to make sure that we are able to provide customers with solutions which can reduce the fuel cost in the production of the products, mainly steel, ceramic, pellets, any other glass, any other industrial products. And these challenges are part of Indian ecosystem, and rather than fighting and probably crying over them, we have to find solutions to move forward. That's the Indian ecosystem. That's what I've learned from last 15 years, and that's what I would like to move on. And I'm here if anybody has any questions on my presentation. Thank you.
Thank you so much, Mr. Kumar. We have few of our participants who have questions. We have Mr. Shivaratya Sen, who is joining us now. Mr. Sen, please go ahead and ask your question.
Yeah, hello. Am I audible?
Yes, Mr. Sen, we can hear you. Please go ahead and ask the question. Also mention the name of the speaker to whom you're asking the question to. Sure.
Yeah, so this is Shiva Sen. I'm from Air Products. And my question goes to Mr. Sharma, especially regarding the challenges, perhaps, what we understand regarding fixed bed gasification technologies. And we understand that typically fixed bed gasification technologies and the type which you are using can only handle fairly large lumps of coal, which means the fine coal particles need to be separated, and this would end up on a large pile and also mounts, creating an environment hazard.
Mr.
Second
Sen,
is the...
I'm really sorry to interrupt you. but Mr. Sharma has had to drop off this call. He had an urgent meeting and he has
Oh, I
dropped
see.
off this call. So would you require any clarification in the question from the speakers that we have now, Dr. Andrew and Mr. Varun Kumar of Data Energy?
Okay, maybe, because one second, let me just, okay, Mr. Sharma is in there. So maybe a question for Mr. Varun Kumar as well as if he can take up. And I think, Mr. Kumar, you are also using the fixed bed technology, that is what I saw.
Yeah.
And of course, your applications are a little different. Whereas, in large scale fixed bed technology where you're converting coal to chemicals per se, what we understand that there are several challenges, and I may just quickly, go through a couple of points here. Like one is of course the fine coal particles cannot be taken. It has to be separated, and it ends up in large pile and mounts, creating environmental hazard. Second is low temperature process, which makes it inherently inefficient, especially for unreactive coals, where the conversions are less than 90% carbon conversion compared to our dry feed air products, which is the fuel technology, which can go up to 99% carbon conversion. And also there are other issues in terms of low temperature process.
Can you repeat once again?
So,
Anisha, I'm back on system.
Okay.
In case I think some gentlemen wanted to ask some question, I can reply. Carry on. I'm available in this session now. Please.
Right. Mr. Sen, I would request you to reframe that question a little concisely so that Mr. Sharma can answer your question.
Sure. So thank you, Mr. Sharma, for coming back on the stage. I was just commenting a couple of things on the technology that is being used in Angul, which is a fixed bed. And what we understand, there are certain challenges in terms of using fine coal particles, challenges in terms of, also carbon conversion is typically low because it's a low temperature process. And also a lot of volatile organic compounds are generated like phenols, which normally create havoc in the downstream syngas treating process. Plus, there are other issues in terms of black water generation, which needs to be treated, in the syngas cleaning section. And also, there's quite a bit of methane, up to 8 to 10% methane.
Yeah, I think you asked a couple of questions together, one by one. First of all, methane is not an issue for us. Because whatever methane we have, CH4, like maybe 6% or 7%, though we can reduce it there if we add more oxygen. But all this methane we are utilizing in our DRI. So we maintain normally 4 to 6% of methane. So there is no issue, number one. Number two, we have a zero discharge system. From the plant, nothing goes out, whether it is any kind of water, and we circulate all of the waters within our premises. So there are no issues as far as whether it's black water or anything else or sediments. So because we are at zero discharge level organization, we don't allow any liquid to go out. And we have in-house processing and recycling system. The third is coal conversion. You see, we are getting coal after washing 3,500 kilocal, the overall calorific value. So our coal conversion, if we see on apple-to-apple basis, is more than 70%. And it's not a matter of low temperature versus high temperature. Because nowadays the syngas is also produced at 400 degree temperature with the steel ball technology. So the steel ball technology is that whatever the city waste, municipal waste is available in any of the cities. So there are a couple of companies from Finland and also from America. They are converting, they preheat the steel balls and they put into vessel, and then it is converted into CO, the carbon monoxide. And the efficiency level is pretty good, and you don't need to burn the waste. So basically, conversion has no relation with in my view, no relation with temperature. Conversion has a view that how much CO from where you can extract. So these were the 3 questions. Any other question left? Then I can reply. And one more thing, the best is you please visit to us and see yourself what we are doing. And since Air Products is a good company in terms of technology, we'll learn from you. And we are utilizing around 18 to 20,000 nm³ of oxygen into this process. Maybe in some other processes, if it is not same, maybe more or less, maybe plus minus 10% oxygen. And this is what our experience is. So ultimately, the question is whether we get value for money. Yes, we get value for money.
Right. Mr. Kumar, would you like to add something to this?
I would like to add one point. You see, the energy conversion of coal is dependent on pressure. And the capex of the plant is directly correlated to the operating pressure of the gasifier inside. So in my arena, for fuel, when we generate coal gas for fuel, I have learned that to operate plants at low pressure is much more beneficial because the total capex and the attribution of interest rate on the plant is much lower. So therefore, I would say that even if you are compromising on conversion in the fixed bed, even if you are compromising on the energy conversion, our plant total capex are much lower than the plants which they are saying, right?
All right. We have Roshan Singh, Deputy Manager, Coal Preparation, Central Coalfields Limited, Ranchi, with a question now. Roshan, go ahead, ask your question.
Good afternoon, everyone. I have 2 questions. I mean, I have more than one question. So I will take this opportunity and permission from Anisha ma'am to ask them at once. My first question is to Sharma sir, and it is regarding the cost he quoted somewhere around $6 per MMBTU of the syngas for the plant at JSPL. Sir, my question is, does the cost include the washing cost of high ash coal as well? And my second question is, since the first session, I have been hearing that has limitations when it comes to high ash.
Mr. Singh, we are unable to hear you clearly. Can you repeat your second question?
The first question I could understand. The cost you are telling, it is $5 per MMBTU, and yes, it includes the washing cost. And but we do not take the yield because whatever we do the washing. So there are 2 kind of coal available. One is lump coal from 5 to 50 mm, and the other is coal fines, that is below 5 millimeter. So what we do, 5 to 50 mm we take to the gasifier, and below 5 millimeter we take to our power plant. So that is again a fuel for us, and we take it at par value. But yes, the overall, the washery processing cost is included in this $5 per MMBTU, and that is a direct variable cost, or you can say the actual cost, plus the overheads, not overheads, sorry, plus the interest and depreciation of the plant.
Right. Mr. Singh, go ahead and ask your second question.
The second question is to the entire panel. It is open to the panel. That since morning we have been hearing that when it comes to high ash coal, there is a limitation of the technology that is available. But we are still not quantified this high ash. At what ash does the technology restrict or has limitations in usage, economically and viably?
Yeah, I will tell you my case because we are in a fixed bed business. We do not have entrained flow or some other technology. In our case, the high ash means 35 to 36% of ash being fed to the gasifiers. And since that much of that kind of coal is not easily available in India, so what we do, we bring coal of 48 to 50% and then wash it in our washery. Sometimes we get coal also at 38, 39%, then we blend it. And some of the mines in Odisha, they also have coal even 33 to 34%. But rarely we get that coal, otherwise we could directly gasify it. Normally, you can say that from 33 to 50% of the coal is available in India, in Odisha, and we clean this coal, and wherever the ash is low, then we blend it with the washed coal.
So, Anisha, I'd like to add something.
The other processes, I think somebody else can reply you.
Yes.
Like trend flow or some
I'd
other
like to-
Right. I think Mr. Kumar wants to add.
Sharmaji, I'll add on to what you said in a general sense. So high ash does not mean that it is the quantity of ash. There are various variables. One of them is ash fusion temperature. Second is flowability and presence of heavy iron ore and alumina sort of materials inside the ash. And third is the overall density of the coal because of ash, the weight of coal. So as JSPL, that the Budbil gasifier, there the problem was the weight of the coal. Now, if the ash is more, the weight of coal is more. Therefore, the fluidized bed cannot work. For fixed bed, the problem is the flowability of the fluid and the fluidity of the ash. All in all, above 40%, all these variables together go out. So you can take 40% as a cutoff number for the ash being said as high for coal gasification.
All right. I'm going to ask another participant. Yeah, I've added him to stage. We have Mr. Saurabh Palsania who wants to ask a question. Mr. Palsania, please go ahead and ask your question. He's from Danya Bharat Cement.
Yes. So, good afternoon, Mr. Sharma. I just want to ask a question from you. This is regarding, what are the impacts on your system? I mean, is there any, after gasifying the coal, is it making an impact on the byproducts or the waste that you are generating in a steel plant?
No, because gas is coming in the cleanest form.
Yeah.
The syngas, it is H2 and CO and plus methane and some other gases like nitrogen. And it does not contaminate our process as far as the steel is concerned. And as I told you, sulfur is less than 2 ppm. And physically it is less than 1 ppm. But the system is designed for below 2 ppm. So there is no impact of any kind of adulteration or any kind of problem in steel making. So I would say it is the cleanest form of steel when we produce through DRI route and then finally through electric arc furnace. And there are no tramp elements available. So it is only iron ore, and whatever kind of iron ore pellets we use, I mean, that definitely plays a significant role, how much ash we have in iron ore and what is the total silica level, alumina level. That is a different issue. But from syngas side, there are no issues.
And I mean, the slag that you are generating as a byproduct in steel, that will be impacted or it will remain the same because it is out of the iron ore?
Yeah, it will remain the same. There is no issue because we are just doing the process of reducing the iron ore pellets. And so whatever the contents in iron ore, like Fe content in iron ore are available, those contents are well preserved. And finally, we get the same yield, whatever you get through any other route like natural gas. We also have a plant in Oman that is based on natural gas. So the results are similar for both of them.
One more question, sir. You mentioned in your speech that you are selling ammonia also. Maybe that this is because of gasification, is it added more into the system? That's why it is being generated and you are selling it, or it was a part of past process only when you were not gasifying the things?
No, ammonia is part of gasification unit. Because when we clean the gas, syngas has to be free from ammonia. So we have ammonia recovery plant. So after the raw gas, it comes from the gasifiers. It goes to a cooling system where we produce steam also. And then from cooling, it goes to Rectisol. And from Rectisol, the stream goes to recover the ammonia. And then finally, we recover ammonia in liquid form. So, for each a million Nm cube of syngas, there is a particular percentage of liquid ammonia what we can generate. That is about 3.7%, and that we take out. Similarly, the sulfur. So whatever sulfur is in coal, like in India, the sulfur in coal is 0.7, 0.8, sometimes 1% also, sometimes more than 1% also. So the entire sulfur is recovered. Whatever sulfur is found in the form of SO2, that is the free sulfur, that goes away, but we capture the entire sulfur and then finally we pass it through. So the sulfur is a byproduct, you can say. Then tar is a byproduct. Then naphtha is a byproduct, and so is the ammonia is a byproduct.
Right. We have another question. Yes, it's Mr. Narendra Agnihotri. Mr. Agnihotri, please go ahead and ask your question.
Yeah, hello. Can you hear me?
Yes, we can hear. Please ask your question. Who is this question for?
Yeah. My question for whole panel. So this is not the specific question. Just I want to ask you for the gasification of pet coke or coal, the hydrogen by carbon monoxide ratio is around 0.5 to maximum 1. But the best available technology is giving 0.9 and 1. This is that. So for if we are going for the natural gas, the ratio is much more higher, around 2 to 2.5. So because the plant will be bigger, why we are not thinking about how we can convert direct, because the coal is majorly from the carbon business, majorly the big carbon, because carbon is around 80 to 95%. So why we are not converting, why we are going with the gasification technology side, we are not thinking about to convert into the polymer side, directly convert into the polymer without converting to the gasification and other things. Because this is an energy intensive process also. So a lot of energy is consuming in this process.
Right. Mr. Sharma, would you like to take this question?
I think Mr. Agnotri's question is that why do we need gasification at all? Am I right?
Yes, because this is the very old technology. Gasification is very old technology. More than 50, 60 years, the gasification is going on. And because I think in the 20, 30 years, any technology should be in the full of mature form. But still we are facing the problem to putting the gasification plant and facing a lot of challenges to putting the plant, and sometimes the plant is not running up to the full capacity. So why we are not thinking about why we are going into the gasification side? We are not thinking about to convert coal or pet coke to directly into the polymer, because this is also the carbon business. Hydrogen is very less. So hydrogen to carbon ratio is very less. So we are going into the least economic way. We are not thinking about the bigger way in this sense. I am not talking about India, maybe in the whole world.
No, actually, I'm not qualified enough to reply you because we need gas. That's why we are gasifying it. We are not. We don't need any polymers. So our requirement is gas. So
high value chemicals.
1 minute, please. We need a substitute to natural gas to make DRI. So if you have some technology in mind, I do not know. Maybe Dr. Andrew can throw a light whether coal can be directly converted into the polymers you are telling. Maybe and may not be. It is not in my knowledge. So what is our requirement? We need gas. That's why we are converting coal into gas.
Right. Dr. Andrew, would you like to add to this question? Mr. Agnihotri wants to know, can't you convert coal directly to polymer? Why are you getting into gasification at all?
Well, I'll pick up one of his earlier points getting to that question to start with, if I may. Saying this is an old-fashioned technology. This is a technology that's been around a long time, but the variants that are now starting to be used in the power sector and the coal to chemical sector are very modern technologies, particularly the entrained flow systems. And I think you have to recognise that I take his point entirely that the carbon to hydrogen ratio is what it is. It's a high carbon, low hydrogen ratio, which is not ideal. But it's been shown consistently in China, the United States and its gasification program there, and particularly in Japan, either for chemical components or power, excuse me, you can achieve it with the more modern plants, and you can, and particularly, I think, if you're making chemicals from coal, you're looking at it from a security of supply issue. It isn't the ideal place to start with, but if you've got coal and want to make a high grade product, it's a good way to go. But as I said in my presentation, it can be vulnerable to price falls in oil and gas versions. So there's no one-size-fits-all solution to any aspects of this. Gentleman has just spoken to quite rightly about his process. Mr. Schumer has talked about his process. That's fine, and each one will be different. But again, from my sector, which is the power sector, the opportunity to take advantage of these very modern gas turbines is a tremendous push for taking forward the integrated gasification concepts. Thank you.
Right. Thank you, Dr. Andrew, for answering that question. There is no one size that fits all, and you have to find out what your need is. And then go ahead and decide which technology and which product you're going to use. I'd like to thank all our speakers for joining us today with their presentations and talking to us about how this technology being used and what are the potential utilizations for coal gasification. Thank you so much for joining us this afternoon. We are going to take a 30-minute break and reassemble again at 4:30 to talk more about coal gasification. I would urge all participants to use this break to network with each other, to say hello, to find out what is happening now that we haven't really even physically met each other for a very long time. Do use the networking forums, do visit our expo, connect to technology and solution vendors. There's a lot happening in this two-day conference. We have the Gasification India 2020 session going on in Hall 1. We also have the Waste to Energy session going on in the other hall. So do utilize your time to catch up on all that is available and who all are available. Thank you so much for joining us. Thank you, Dr. Andrew, Mr. Sharma, Mr. Varun Kumar. Thank you so much for being here.
Thank you. Thank you.
Thank you very much. It's been a pleasure.
Thank you.